Question 11c, given that q is equal to 8d squared, we need to find the other two real roots. So we've got our polynomial written out here in red, and in this red box here, we've got the sum and product of roots theorem. So we're going to need to use that to solve this problem. So we will write down what we know so far. So we know one of the roots is 1, and we know two other roots. We know one is di, and the other is negative di. It's a complex conjugate. So what we'll do is we'll call our other roots that we want to find out, our real roots, root 1 and root 2. And now we can plug these roots in to our sum and product of roots theorem, and we'll get some simultaneous equations, and then we can solve for R1 and R2. So the sum of the roots then, that's going to be R1 plus R2. So these are the real roots that we want to find out. Plus 1 plus di minus di. And that is going to be equal to 3, because for our sum of the roots, it's going to be negative a sub n minus 1 over a n, which we worked out before, is equal to 3. And just rearranging this and simplifying it a bit, we're going to get R1 plus R2, and then the di's will cancel, and taking the 1 to the other side, we're going to get that equal to 2. Then for the product of the roots, we're going to get R1 times R2 times 1 times di times negative di, and that's going to be equal to this blue part here that we've got, so negative 1 to the power of n times a sub 0 divided by a sub n. So for our problem, n is equal to 5, so we're going to get negative 1 to the power of 5, a sub 0, well, that is q there, times q, and a sub n, that's just the coefficient of x to the power of 5, which is just 1, so that equals negative q. So just tidying up this equation a bit then, we're going to get R1 times R2 times 1, so we'll just leave the 1 out, times di times negative di. So d times negative d is negative d squared, I times I is I squared, which is negative 1, so we're going to get d squared, and that is equal to negative q. And we know that q, given in the question, is 8d squared, so then we can write R1 times R2 times d squared is equal to negative 8d squared. And now we can cancel the d's, because we're assuming d is not 0, because we're told that di is a root and it is imaginary. So if we've got an imaginary number, well, then the imaginary part is not going to be equal to 0. So we'll cancel these d squareds there, and then we get R1 times R2 is equal to negative 8. So now we have two equations. One is up here, R1 plus R2 is equal to 2, so if we call that equation 1, and this equation that we've just got down here, R1 times R2 is equal to negative 8. So we can solve those equations simultaneously and find our real roots, which we've called R1 and R2. So I'll just section this bit off here, and then we'll continue working to solve to find R1 and R2. So from equation 1, we get R1 is equal to 2 minus R2, and just plugging that value of R1 into our second equation, then we're going to get 2 minus R2 times R2 is equal to negative 8, and expanding that out to get 2 R2 minus R2 squared is equal to negative 8, and rearranging that, now we're going to get R2 squared minus 2 R2 minus 8 is equal to 0. So you can either use your calculator to solve that, or this one just factorizes quite easily. So we're going to get R2 minus 4 times R2 plus 2 is equal to 0. So R2 is equal to 4, or r2 is equal to negative 2. So it doesn't matter which one we pick to be our root 2, because it's going to work out either way. So if we pick r2 equal to 4, well then r1 is going to equal negative 2, and if we chose r2 equal to negative 2, you could plug that back into the equation 1 and you'll get our root 1 is equal to 4. So our two roots then, I'll just pick this one here, I'll call that one root 2, so that means root 1 is going to be negative 2. So our two roots are root 1 is equal to negative 2 and root 2 is equal to 4. Okay, and that is question 11c.